The story of industrial tomato sauce begins in massive agricultural fields dedicated exclusively to growing special varieties of tomatoes. These aren't the round, juicy tomatoes you buy at the market for salads, but varieties specifically developed for industrial processing. They have a more oval shape, thicker walls, fewer seeds, and lower water content. These characteristics make them perfect for turning into concentrated, thick sauce. Farmers plant millions of these plants in fields that stretch for miles, using automated irrigation and fertilization systems controlled by computers. For months, the tomatoes grow under intense sunlight, absorbing nutrients from carefully prepared soil. What's fascinating is that harvesting doesn't happen gradually as you might imagine. Entire fields are harvested in a single day using monstrous machines called tomato harvesters that look like something out of a science fiction movie. These gigantic machines slowly advance through the rows, ripping entire plants from the ground, shaking them violently to separate the ripe tomatoes, and discarding the plants back onto the field in one continuous, brutal motion. Inside these harvesters, human workers sit on platforms while the machine operates, quickly inspecting tomatoes passing by on conveyor belts in front of them. They have only fractions of a second to identify and remove green, rotten, or damaged tomatoes before they fall into the huge collection bins. It's exhausting, dusty work under the scorching sun. Approved tomatoes fall into trucks that can carry up to 20 tons of fruit. What's surprising is the speed. A single harvester can process more than 50 tons of tomatoes per hour. The loaded trucks go directly from the field to the processing factory, usually located just a few miles away. The time between harvest and processing rarely exceeds 6 hours, because tomatoes begin deteriorating rapidly once separated from the plant. At the factory entrance, each shipment is inspected and analyzed. Random samples are taken and analyzed in laboratories to measure sugar content, acidity, color, and possible contaminants like pesticides or heavy metals. Approved tomatoes are unloaded into enormous reception hoppers that can hold hundreds of tons. From there, conveyor belt systems carry them toward the first crucial stage, industrial washing. The tomatoes pass through long channels filled with constantly moving water, where air bubble systems and pressurized water jets remove dirt, leaves, insects, and any surface contaminants. But here comes something truly surprising that most people would never imagine. The tomatoes also pass through X-ray detectors and high-speed cameras that photograph each tomato individually. Artificial intelligence software analyzes these images in milliseconds, identifying internal defects invisible to the human eye, like internal rot or insect damage. Compressed air jets automatically expel defective tomatoes from the production line. Tomatoes that pass this technological inspection continue toward density selection tanks, where they float in salt water. Good tomatoes sink while damaged, or hollow ones float and are removed. This multiple selection process ensures that only the best tomatoes continue. The selected tomatoes now enter a truly dramatic phase, simultaneous peeling and crushing. Enormous rotating drums receive tons of tomatoes and expose them briefly to superheated steam or boiling water at nearly 100 degrees Celsius for 30 to 90 seconds. This thermal shock causes the tomato skins to loosen instantly. Immediately afterward, the tomatoes pass through rubber rollers with rough texture that gently rub the fruit, removing the loosened skins without damaging the pulp. The separated skins are sucked up by vacuum systems and collected for other uses, such as composting, animal feed, or even lycopene extraction, the antioxidant that gives tomatoes their intense red color. The peeled tomatoes look strangely pale and shiny, completely naked. They then enter industrial grinding machines with rotating blades that spin at dizzying speeds, reducing tons of whole tomatoes to thick pulp in minutes. The sound is deafening, and the aroma of fresh tomatoes fills the entire factory with an almost overwhelming intensity that would make any visitor feel instant hunger. The freshly crushed tomato pulp is pumped through pipes toward enormous cooking tanks that can hold thousands of liters. This is where the real transformation from raw tomatoes to sauce occurs. The pulp is heated to temperatures between 85 and 95 degrees Celsius, while giant mechanical agitators constantly mix it to prevent burning at the bottom. During this cooking process that can last from 30 minutes to several hours depending on the desired concentration, the natural water from the tomatoes gradually evaporates, concentrating flavors and thickening the mixture. But here comes something very few people know. During cooking, the pressure inside these tanks is artificially reduced, creating a partial vacuum. This allows water to boil at lower temperatures, evaporating faster without overcooking the tomatoes, which better preserves the bright red color and fresh flavor. However, this evaporation process also eliminates volatile aromatic compounds that give fresh tomatoes their characteristic smell. To compensate, many manufacturers capture these aromatic vapors and condense them to add back later. After reaching the desired concentration, the sauce passes through refiners, which are basically ultra-fine industrial sieves with microscopic holes. The sauce is forced through these sieves under high pressure, separating seeds and any fiber or skin that still remains. What comes out is a perfectly smooth and homogeneous sauce, without any grainy texture texture. The removed seeds and fibers again aren't wasted. They're processed to extract tomato seed oil, an increasingly popular gourmet product, or converted into ingredients for animal feed. The refined sauce then receives its seasonings. Contrary to what many believe, commercial tomato sauce is never just tomatoes. Salt, sugar, spices, herbs, vinegar, onion powder, garlic powder are added, and often additives like citric acid to adjust acidity, calcium chloride to maintain firmness, and preservatives like sodium benzoate or potassium sorbate in some brands. Each manufacturer has their secret, patented formula. Ingredients are mixed in exact proportions calculated by computers, creating consistent flavor profiles batch after batch. The seasoned sauce now faces its final test: pasteurization and sterilization. This stage is absolutely critical for food safety and product shelf life. The sauce is pumped through plate heat exchangers where it's rapidly heated to temperatures between 85 and 110 degrees Celsius, depending on the method used. Normal pasteurization kills most bacteria, yeasts, and molds, but not their spores. For products that will be sold refrigerated, this is sufficient. But for sauce that must survive months on shelves at room temperature, complete sterilization is needed that reaches temperatures of 121 degrees or more, killing even the most resistant spores of dangerous bacteria like Clostridium botulinum, which causes deadly botulism. What's fascinating is that these extreme temperatures are maintained for only seconds or a few minutes, just enough time to sterilize without overcooking the sauce and ruining its flavor. Immediately afterward, the sauce is rapidly cooled through other heat exchangers using cold water or refrigerated glycol, instantly stopping the cooking process. The sterilized and still hot sauce is immediately pumped toward the filling machines in a completely sterile environment. This timing is crucial. Filling while hot helps create the vacuum inside the container that will preserve the sauce. The filling machines are marvels of precision and speed, filling hundreds of bottles, cans, or jars per minute with milliliter accuracy. For glass containers, the empty jars and lids are sterilized with steam or boiling water immediately before filling. The hot sauce enters, the headspace is purged with steam to eliminate any air, and the lid is hermetically sealed while everything is still hot. As the container cools, the steam condenses, creating a vacuum that sucks the lid down with that characteristic pop you hear when opening a new jar. This vacuum is what actually preserves the sauce, preventing microorganism growth. For Tetra Pak containers or aseptic bags, the process is even more complex, requiring completely sterile environments where not a single bacterium can enter during filling and sealing. The filled containers pass through automated inspection systems that verify multiple parameters: correct fill level, adequate hermetic seal, absence of visible contamination, legible barcodes, and correctly applied labels. High-resolution cameras and laser sensors inspect each container in fractions of a second, automatically rejecting any that don't meet exact standards. Approved containers receive printing of manufacturing date, batch number, and expiration date using inkjets or lasers. This information is fundamental for traceability, allowing exact identification of when and where each bottle was produced. The containers are then grouped into cardboard boxes, palletized, and moved to gigantic warehouses where they await distribution. Some premium brands still use the traditional water bath method, where already filled and sealed jars are submerged in boiling water for 30 to 60 minutes, guaranteeing complete sterilization even if something went wrong during filling. This method is slower and more expensive but produces extremely reliable results. A final surprising aspect of industrial tomato sauce production is the chemical manipulation of color and consistency. The intense red color we associate with quality tomato sauce doesn't always occur naturally, especially when tomatoes are cooked extensively or processed from certain paler varieties. Some manufacturers add small amounts of paprika extract or even natural beet coloring to intensify that vibrant red consumers expect. Consistency is also frequently manipulated. If the sauce is too liquid after cooking, thickeners like modified starch, xanthan gum, or pectin are added to give it that thick texture that adheres perfectly to pasta. Ironically, these additions often appear in small print on the ingredient list that few consumers read. Quality control laboratories analyze each batch using spectrophotometers to measure exact color, viscometers to measure consistency, and refractometers to measure solids content. Only batches that meet precise specifications are approved for sale. This entire process transforms humble tomatoes into a standardized global product, but also completely distances us from the authentic flavor of fresh tomatoes cooked at home.